Hi, in this video, we will be now covering functions of more than one variable. So it's an extension from our previous video. So it's really about functions with several variables, and we'll look specifically at a function with two variables. And really that's because once you extend it to two variables, you are able to extend it to Rn yourself. And so what does it mean to be a function of two variables? Well, it assigns an ordered pair to a unique real number, and then you just take the image of this and it will be the range of this function. So this is a real value function of multiple variables, so it's a scalar. But it's also possible that this multiple variable function results in a vector. And we'll see more examples later on. But first, let's understand it at a scalar first. So this is a real value function with multiple variables. And one case of that is the graph of fxy is a plane. So basically, your z equals to 6 minus 3x minus 2y. And by plugging in what is x and y, you find the height of this point, z. And so now we generalize our idea of planes to what is known as surfaces. So a surface is a function of two variables in R3, and the graph is the set of x, y, and z points. So now your function is just z equals to some two variable function. And this graph is known as the surface. So you can think of it as your points in xy plane, and then you draw out this surface over here. And so this is how you visualize the function. So you just send all these points upwards, and once you gather all the points, you get this surface. So if the function is linear, then you get a plane. Else, you just get some weird curved surface. Another way of visualizing a graph is of course using what is known as a level set as well. And a level set, you can think of it as contour lines. So for example, you got this surface over here. At this height, you can just gather all the points there, and then you drop it down into, and then once you cut this surface with a plane parallel at this height to the xy plane, then of course you can project all these points down and just see how the graph looks like below. And so a level curve, this is known as a level curve or level set of two variables, is a curve in the xy plane where fxy equals to some constant. So the k level set curve is when fxy equals to k. And when we say that the level sets are close together, that means the function is very steep. And the level sets are far apart, then it's flatter. So let's just take an example to see it. So we have the function 4x squared plus y squared. And really, if you let this be some constant, let's say 1, then you get this ellipse. 2, you get an ellipse. 4, you get an ellipse. And really, so this is at 4. So when you project it at distance 4 up, you get this here. And then you can just draw for different heights. And then in the end, when you gather all of that, you understand the entire surface. But to break it down easily, you can just represent it with level sets. And so really this could be our first time encountering multiple variables. So you have to take a while to get yourself familiarized with using two variables now. But really, once you understand it by practicing more, you see that it's not too far off extension from having one variable case. And while we can think of a surface as a graph of a function, or we can think of it as a level set, or we can bring down the surface to a level set, sometimes we want the surface itself to be the level set to understand a 4-dimensional function. And so we can describe surfaces as the level sets depending on 3 variables. And so sometimes it's difficult, and so this function, the original function now sends this 3-dimensional object to a 4D space. And so if the graph of it will be in 4 dimensions, so you can't draw the function. But you can still draw the level set of the curve of this function and represent it with surfaces. And then now you can visualize it. So you can see the utility of using a level set. For it can bring down a 4-dimensional abstract object to 3 dimensions. And this level set is known as a level surface. And really, once you extend it to 3 or more variables, you can just drop it down to a smaller level by using a level set. So, for example, you have this 3-dimensional 3-variable function which represents spheres. So each sphere is like a level surface, and then you want to project it on, and then you want to find its function to give you the point 2. So you're just taking this sphere equals to 2. And so that's how you really understand these level surfaces. So really, this is just a quick introduction into multivariable now, and we'll see more examples as we transverse along this series. Hope you have enjoyed this short video. I'll catch you in the next one where I talk more and use more about multiple variable functions already. So I'll see you again. Feel free to like, share and subscribe. Bye.